Have you ever looked up at the moon and wondered how it got there? For decades, the leading theory has been the giant impact hypothesis. It suggests that about 4.5 billion years ago, a Mars-sized planet named Theia slammed into a young Earth. The debris from this cataclysmic collision then coalesced to form our moon. Material from Theia became part of both the Earth and the moon, forever linking the three bodies. This idea has been around since the first Apollo samples were analyzed over 50 years ago. But there's always been a huge missing piece of the puzzle. Theia itself, the planet, was completely obliterated in the impact, leaving no direct evidence behind. Scientists couldn't be sure where it came from or what it was made of. Was it a local neighbor from our part of the solar system, or a distant wanderer from the outer reaches? Its origin has been one of the great mysteries of planetary science. But now, exciting new research is finally shedding light on Theia's long-lost home. A team of scientists from France, Germany, and the United States has managed to trace Theia's origins by looking deep into the chemistry of ancient rocks. What makes this research so thrilling is that it's like a cosmic detective story. As astronomer Jake Foster from the Royal Observatory Greenwich put it, we're talking about a planet that hasn't existed for 4.5 billion years. It was essentially vaporized, and yet, with remarkable precision, we can now figure out where it came from. This isn't just about understanding the moon's past. It's about piecing together the chaotic, early days of our own planet's history. It is a testament to how far science has come that we can reconstruct an event of this magnitude from so long ago. So how did they do it? The team used a technique that's a bit like planetary reverse engineering. They analyzed rock samples from Earth and, crucially, those precious samples brought back from the moon by the Apollo astronauts. Inside these rocks, they looked at isotopes. You can think of isotopes as unique chemical fingerprints for different elements. Scientists have known for a while that the isotope ratios in Earth and moon rocks are surprisingly similar. This similarity has actually been a problem, making it incredibly difficult to distinguish the original material from early Earth from the material that came from Theia. The breakthrough came when the researchers focused on the isotopes of specific metals like iron, chromium, zirconium, and molybdenum. The key is that materials that form closer to the sun have a slightly different isotopic signature than those that formed farther away. This is because they were created under different temperatures and conditions. The team then used powerful computer models to run hundreds of possible collision scenarios. They tested what combination of an early Earth and a Theia from different parts of the solar system could produce the exact isotopic mix we see in the Earth and Moon today. After crunching all the numbers and comparing the models to the real-world rock data, the conclusion was clear. Theia's chemical fingerprint most closely matched that of an object that formed in the inner solar system, even closer to the sun than where Earth formed. This discovery turned some previous ideas on their head. For a long time, a popular theory was that Theia might have originated farther out in the solar system, beyond Earth's orbit, and migrated inwards before the collision. But this new evidence strongly points to Theia being a true inner solar system native. This finding has huge implications. It helps us build a much clearer picture of the environment in which the terrestrial planets Mercury, Venus, Earth, and Mars were born. The early solar system was a crowded, chaotic place, with planet-sized objects zipping around and frequently colliding. Knowing that the object that helped create our moon was a close neighbor gives us vital clues about the distribution of materials and the dynamics of planetary formation in this region. It suggests that the building blocks of planets in our immediate cosmic neighborhood were more similar than we might have thought. This research isn't just about solving one mystery. It opens up new avenues for studying how planets grow, collide, and evolve. By understanding the specifics of the Earth-Theia impact, scientists can refine their models for how planetary systems form everywhere in the universe. Each piece of evidence, like the origin of Theia, helps us understand the sequence of events that led to the creation of a planet capable of supporting life. It's a reminder that the calm, familiar face of the moon we see today is the result of an incredibly violent and dynamic past. The story of our planet, its companion, is still being written, one rock sample at a time. Thanks for watching, and if you found this journey back in time fascinating, be sure to like this video and subscribe for more deep dives into the cosmos.